In this video, I'm going to show how to calculate soil moisture index (SMI). The soil moisture index or SMI is the measurement that quantifies the amount of water in the soil, and the scale is 0 to 1. So to calculate soil moisture index, we are going to use Sorghum research field, and this is the image from the Sorghum research field. This is RGB or true color image. And to calculate the soil moisture index, we need the thermal image, right? So we have the thermal image of this field, right, which is this one, and it's the same field, okay? So this is the thermal image of sorghum research field. And to calculate the soil moisture index, we have to remove the vegetation from our image, right? Because we are going to calculate from the soil. So to remove vegetation from our image, we have to divide our image into two parts, two classes, soil and vegetation. So to do that, ArcGIS Pro has very useful tool, which is unsupervised classification, right? To get on unsupervised classification, first we have to click on our image, which is thermal image, and go to Imagery, classification wizard, and we have to go to unsupervised classification because we are giving task to our software to do the classification. Okay, it will do by itself, and it will do by pixel based. Okay, and since we did not create any schema, we can use the default schema. It will do its job as fine, and we can leave test as it is and click on next. So, and also, since we are going to classify the image only two parts, only in two classes, so maximum number of classes we are going to use is two, and rest we can keep as it is, and then we can just click on run. It has classified our image into two parts, right? We can always change the color of the image. Let's I'm giving soil as soil color. Let To double check that, we can always click on this. Okay, so this is the original one. See, the vegetation and the soil, right? So the soil is yellow, and we can change the vegetation color to green, and we can uncheck the original one. So soil and the vegetation, it has divided our image only in two classes, soil and vegetation, right? So now we have to remove our vegetation from our image. So to do that, ArcGIS Pro has another useful tool, which is in geoprocessing. We just have to type Set Null. It will remove whatever pixel the image has, to just make it transparent, make it zero, make it will just remove whatever the data it has. So our input data is the classification. Okay, so we are going to use preview classified, and this is the conditional class, and it's giving the logic like where do we want to make null. So we want to make null in the value, and when the value is equal to vegetation, right? Vegetation is 1. So when the value is equal to vegetation, which is 1, set to null, right? And if the value is not null, we are going to keep our original image, which is our thermal image, right? So if the value is 1, which is vegetation, it will just remove the data. And if the value is not 1, or if the value is 0, it will just keep the original data, which is our old mass, right? So, and we can always rename our output. I'm going to just do a set null and click on run. It will take some time to set the to change it to null, and see, it has just completed it. And we can double check it. I'm unchecking this one, and this is my original image. And what else I'm missing? See, I can see the vegetation, the true color vegetation from my set now, from my image, right? See, all the vegetation are coming out. So yeah, the signal has properly worked. So we have only the soil in our image, and now we can calculate the SMI, soil moisture index. To calculate, we have to go to geoprocessing and search for raster calculator, image analyst tool. In raster calculator, we are going to use the formula of soil moisture index, which is land surface temperature of maximum, which is our the maximum temperature, right? 68 68.1018, and minus, we have to subtract soil temperature, right? Land surface temperature, which is our set now, and close parenthesis, divide by, open parenthesis, divide by maximum land surface temperature, which is 68.1018. I'm just using this data, right? Minus minimum soil land surface temperature, 48.9057. Okay, close parenthesis, and we can rename our output. Soil moisture index is SMI, and click run. It will take some time to complete and calculate, and looks like it has completed. We can just uncheck our set now, and this is our soil moisture index, and mm, we can change our data, change our label actually, for our easy calculation and visualization. And I'm going to change the vague negative number to just 0 for the simplification, and we can change the color also of this. So since it is index and like a temperature, and I always prefer green to red. See, if the soil moisture is less, which is higher stress, it is giving me green, right? If the soil moisture is higher, it is giving me red, which is just opposite. So I'm just going to click in invert. So it has just changed it. So everything it has just changed, right? So let me explain to you. So this is the soil, right? Don't confuse it. Get confused. This is the soil. So in soil, the middle part has less moisture, which is soil moisture index, which is very less, right? If I double click over here, 0.01, 0.1, which is very less. Let me find if I can 0.01. Okay, maximum is 0.1, which is less moisture, so it is giving me red. And if the moisture is higher, it is giving me green, right? Close to 1.8 or 0.48 half. Let me check if it has this one. Oh, yes, okay, 0.1, 0.2. So yeah. So if the moisture is less, which is in the middle part of the soil, the index is less. But if the moisture is higher, which is in the around the edge, so let me say something. There is a consistent pattern in all over the image. Uh, the soil around the edge with the vegetation is greener, which means it has higher soil moisture. This is because due to the value of mix up value with uh, our vegetation, like vegetation leaves has been mixed up with our with the soil, so that's why it's giving me higher moisture. But overall, see over this side, I mean the moisture is higher than over in the middle spot, right? So yeah, this is how you calculate soil moisture index. Thank you for watching.